Try to get the final answer without a calculator, making sure your entire group is on the same page. Ready, set, go. What's the final answer without a calculator? I guess you can check it with the calculator if you think you using your notes in your notes. Then make sure your notes are ready to go 30 seconds each out of it. It's like a number of pages. That'll save you paper.
I think it's L and I was thinking it was L and
Alright, 30 more seconds.
so what can you do? So do you see how this one is similar to that one? Or you can just like do it right here. Do it like right there.
I have something you want. It's called supplying tomatoes.
Ooh, economics at such a young age. Okay. Here we go. Who thinks they have an answer? Wait, just one has an answer? Okay, hold on. Let me see hands. Who has an answer on their paper that they think might be right? That's all I want to know.
Possibly.
Here's what I was trying to see. I was trying to see how many people thought they had the answer and then how many groups actually had talked about it. Because if one person had the answer, they should have shared it with the group, gotten or convinced the whole group that it was true, and then the whole group should be like, yeah, we all got it. Does that make sense how it should work? Now, where did that break down? Because I had like 2 people kind of half raise their hands. And I think 3 people, and actually no, 2 people verbally said it and didn't raise their hands. So 4 people total thought they had an answer. Where did the process break down? Maybe not even starting it. Maybe not talking about it. Maybe not convincing the group, right? Some of you need to work on your debate skills. So maybe not being convincing, maybe not talking, and maybe not even starting it. So anywhere that your group broke down, you need to work on. True? I know it's silly, and I'm not going to spend more than 15 seconds on it. There you go. I can watch the clock. Why do I try to make this class so collaborative? Any ideas? Not everyone's good at math. Different brains think differently. I'm going to go to 30 seconds. Different brains think differently about math.
Low test rates.
Maybe. I mean, that's a part of it. But in college, guess how you will survive?
By making friends.
They're hardcore in college, so good luck with that. My sister's a professor. She definitely flunked kids on their final exam because they had a phone that they were sitting on. Who knows if they even actually used it? But nope, sorry, 0. Retake the class next semester. Good try. Oh, you have to drop your major now? Too bad. There goes your life plan. Anyway, coming back. That's not even to speak about cheating at a job one day and getting fired and being like, well, unemployment, there you go. Coming back. Collaboration, this is taking a whole extra minute. Collaboration is going to be key. and that's with your peers, because your professors are going to have office hours that are very slight and few and in between, and it might be during one of your classes, meaning you'll never get to go talk to your professor, so you'll never get help from them. So you either reach out to your friends, you figure out how to use the internet in a way that you actually learn, because you barely ever get points for homework in college. It's midterms. Hopefully you pass the test, and if you don't, well, too bad. Midterm can be 25, 30, 40% of your grade. 3 tests, it's your entire grade. Hope you do well. So you have to learn to work together with others, and others that you might not necessarily be friends with, be comfortable with, or even want to talk to. You have to learn how to work with them. So Emma, friends, kinda, but they're not all going to be your friends. Sometimes it's just like, you can do this, I can't. Can you please help? I'll buy you coffee. And I'll try not to just steal from you. I'll try to actually learn from you in a way that you don't stop wanting to meet with me. Anyway, social skills, they're important. College, it's a thing. My seniors, love you, it's coming soon. My juniors and sophomores, it's coming soon for you guys too. We're trying to get this answer. I had a hand, Nikki, what's up, kid?
I don't have a pencil and nobody around me has pencil.
Struggle. I have a cup on my desk, I have a cup up here, and I have a cup back there. Anyway, you can always look at my cups, borrow, just make sure it gets back in. Okay. Final answer is, oh, I heard someone say it. I know that someone knows the right answer. What's the final answer?
ln of 1 minus
The final answer.
-1.
Negative. Nice. Nice. I heard it. I knew. -1/2. But why?
ln of 1 minus
Was Emma right when she started saying ln of 1 minus? Yeah.
ln of square root of e.
But why am I going to write this as ln of e to the, those fractional power root things actually help? Yes. E to the 1 square rooted is e to the 1/2. Why does that make all the difference?
The quotient from
Oh, wait a minute. What happened to him? He disappeared. Nathaniel, was that your question? Nathaniel. Was that your question? What happened to the ln? What's ln of 1? What's any log of 1? Always?
Yeah.
Ah! 0. ln of 1 is always 0. Why? Because ln is log base e, and I'm asking myself, snail, the question, e to what power is 1? The power will always be 0. Minus, why is that just a 1/2? Where did the ln of e go to? Oh, what's ln of e? What's log base e of e? 1. 1. ln of e is 1, the same way that log base 2 of 2 is 1, and the log base 7 of 7 is 1, and the log base 17 of 17 is 1. ln of e undoes each other. The 1/2 is left, there's a negative, and I'm done. Okay. What are we doing in section 3.3? They're in your notes already. What are we doing? Properties of logarithms. AKA, we're trying to get good at playing with logs. Why? Because the puzzles are coming. Will you be able to handle it?
Yes.
Hopefully. So let's try another one. You're in your notes. Am I solving for anything on this one? No. What do the directions say? Expand. Did we get to write notes down yesterday on expanding? We did on condensing, right? Oh, we did on expanding first, and we got the examples done? Yeah. We did on condensing and got the examples done. Okay, so we haven't gotten to number 3 yet. We're just doing examples. So, ready, set? How do I expand? Okay, I'm going to write this, but some of you are already trying to go to the next step because I skipped it in the last problem. What do I need to think about that square root as? 1/2 power for the whole purpose of using the power property, because when I am expanding, the name of the game, the goal is to simplify the arguments as much as possible. And the way to simplify the arguments are to break the single log down into separate logs using the product and or quotient and or power properties. Can I go farther? Yes.
No. Yes.
No.
What's your brain going to want to do?
Go farther. X squared.
But what is it illegal to do?
Go farther.
Because I can't bring down the 2 because it's x squared plus 1. It's not the entire thing squared, so I can't bring that guy down. Your brain's going to want to split that guy up and be like, yeah, addition is multiplication or something. But check out your properties. Isn't addition only true with separate logs? I need separate logs to come together. Addition in separate logs makes the argument, sorry, I was going to do division, but that's a product property. Addition of separate logs comes together. Addition combines. Addition never separates. Addition can combine, but it can never separate. So therefore, even though I was trying to trick you by writing in equals and expanding the page, there's nothing else you can do. Well, wait a minute. Can't I make that a decimal? Guess. But we don't try to go to decimals if we can avoid it. ln of 6 is the preferred form. And e to what power is 6? I don't know. Nothing nice. So we're going to leave it right there. Well, that's not too bad, guys. I mean, that's the end of section 3.3. So why am I taking a whole nother day on it? Oh. For those of you guys that started homework, which I strongly encouraged yesterday, can you pop it open real fast and be like, when did it get hard? Those of you that, I might have some more examples, so keep your notes open. I might have some other tricks, but open up the homework. Where did it get hard? Mickey?
I need help with 17.
17? Okay, and I heard Nathan say 20. Was there anything earlier than 17? Okay. For those of you that haven't started homework, stay in those notes because you can maybe write some hints down. 16. Oh, and 16's an even. That would be nice. You guys can't check it on Calc Chat. Okay. 16. Oh, you're using your calculator before. Oh, no, change of base. Kiddos, real fast. Just because the directions could confuse you. This says use the change of base formula. Change of base formula says, give me any log and I'll change it to any other log. Here's the struggle. Did they tell you what base to change it to? They just said change it. Based on what I said yesterday, in the scientific and mathematical community, what is the preferred logarithm to go to? Natural log. So if I were you, I would just dun 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 dun. That's it. That's it. I'm doing homework for you. Wait a minute. You guys didn't even ask about number 11. Let's get with him. Okay, number 16, right? What's going on?
What's happening?
This way. I'm trying to get rid of all the marks. Done. Alright, number 16 says to rewrite and simplify. Ooh, I like this one. This is nice. Do you guys remember the example from yesterday? Look in your notes. The one that talked about log of 9 over 300. Okay, it was a problem. It was number 18. Okay, log of 9 over 300. Go look at what we did. Go look at what we did. Real fast. Beginning of notes. It was right towards the beginning of 3. Log of 9 over 300. Does every logarithm end in a nice non-logarithm answer? Gracias. Yesterday, when you guys did examples, we had log base 2 of 8 that went down to 3 halves. Yay! I got rid of the log because 8 is 2 to the 3 halves power. But when we did log of 9 over 300, guys, just skip to the end. What was the final answer? Aw, there's still a log in it. I know. There's still a log in it. But the argument is simpler. Instead of 9 over 300, it's just 3, and I have a nice non-logarithmic part to the answer. I know that might not seem right to you, but it's true. I just wanted you to look at these examples because what is this going to become? Could it become some nice, simple answer?
No.
Maybe. Maybe. But is this one? No. This one's going to be much more like that guy. So, I see a product property, don't you? Better not use power yet because I have 2 different powers on 2 different bases. But product property would tell me to do what?
Put the one on top of the one.
Put the 4 squared and then in addition, right? Separate logs, adding. Are we good? Now what is it legal for me to do? Separate. Well, I've already separated. Bring down that. I heard it. Say it louder. Power property. Bring down the 2 and bring down the 4. 2 squared. Rewrite the 4 to be 2 squared. Now you could, some of you, would be like, well, 4 is 2 squared, then that log is just a 2, because isn't every logarithm the power? But another way of thinking about it is, couldn't we bring this power down 2 now? 2 times 2 is 4. Log base 2 of 2 is 1. The same way ln of e is 1. Log base 2 of 2 is 1. And log base any a of a, that's a property, yeah? So if I can make any argument into a perfect power of the base, do it, because then, haha, the logarithm is gone. But can I do anything to resolve the 3 to be a power of 2? I'm guessing 17 is fairly similar in the same section as asking you to do something like break it apart. I think what I would do, Nikki, is maybe a quotient property and then splitting up 250 to be 25 times 100. I would split up that 250 to be 25 times, not 100, times 10. Whew, my bad. 25 times 10. Wait a minute, there's a 5 in that too. Maybe I would do 125 times 2.
So you just expand. Or no?
You're just rewriting it. So I'm not going to rewrite it. I can't solve too many homework problems. In one section at least. But I would think about it as try to rewrite him. Because what's 125 as a power of 5? That's going to get you to where you need to go. Think about that and rewriting him. Okay, you guys also said number 20, yeah? But what property do you think you should use on number 20? Quotient. And is ln of e a good thing? Yeah, it is. You're going to be able to rewrite it kind of similar to how 2 and 4 was a good thing, or how 125 and 5 is going to be a good thing after you rewrite with your properties. Did anybody get past that section into any of the other ones? And you want to, ooh, there's some good ones. Which one? 23?
I just don't know what's happening.
This one looks a lot like, hey, didn't I write it a sec? Oh, no, did I just erase it? No, I didn't, right here. It looks an awful lot like this one from yesterday, just what's a little bit harder? I have an 8, sorry. I have a log base 2. I have an 8. Oh, guys, we were just reviewing this a second ago. How do you rewrite radicals? If I have x to the a to the bth root, if I have x to the a to the bth root, sorry, I mean that's kind of going to be a hint-ish. That doesn't get you all the way to the answer. But if I have any sort of radical, how does that turn into an exponent, like a fractional exponent?
1/4.
No, this one.
Or would that be x to the a to the
A
1 over b?
over b, yeah. A to the 1 over b, which just tends, technically goes to a over b. So they're already saying 1/4. Ooh, I would do that too. That's a good idea. And then, Nikki, I would look at what we got for log base 2 of 8 to help you out. Let me see real quickly before I see if there are any other homework-ish questions. If I have any other good ones. Oh, I don't? Bummer. Oh, but I do. Can you guys in your notes real fast, kind of in leading into section 3.4? Can you find me x in all of these? A and B and C and D and E and F? Oh, and G. Oh, E is missing. I don't think I like that one. That's okay. Ready, set, find x. Section 3.3 said, can we play with logs? Can we simplify them? Can we break them down? Section 3.4, where we're going tomorrow, says now what? I've been mentioning section 3.4 all chapter. The goal of this chapter is to be able to play. To know the rules. To know the rules and to be skilled in the basics. To know the rules and to be skilled enough in the basic fundamental properties and formulas to be able to play. How do you play? you're like, shh, this is easy, then ace them all. Wherever you're at. The door's open, hang in there. Hopefully the air is turning on. You have 3 more minutes. And being super nice and saying you can use your calculator. You shouldn't need to, but you can. You can use your notes, think about properties. There's the air. I think we're down to about 1 more minute. As best you can, as many X's as you can. There's 6 different ones up here, right? Okay. Let's see if you're a 6 out of 6, 5 out of 6, 4 out of 6, 3 out of 6, 2 out of 6, 1 out of 6, or 0 out of 6. But real quick, the last 5 seconds before your 4 minutes are up. Is this fun if you don't know how to play? No. You're like, what? But if you know how to play, let's see how you did.
Two. I got one.
4 out of 6, 5 out of 6, what else? Someone who's proud of their score, what else? 6 out of 6?
I got 6 out of 6.
6 out of 6? 6 out of 6? Come on, some more 5 out of 6s, 4 out of 6s, those are still good. Where are you? There you go, 4 out of 6.
I got 2 out of 3 of the ones I did.
That doesn't count. Alright.
That's 66.
Alright, that's still 66, almost 67, okay. Now pause. Some of you, by 0 out of 6s, 1 out of 6s, 2 out of 6s. Okay. We're doing this section tomorrow. These are the simple, these are the basics. Some people are ready and some people aren't. It's okay. What are you doing tonight? Section 3.3, which is working on the basics still. Now, they're not all easy, but they're working on the basics of, okay, do you know what to do with a log? Do you know what you can do with a log? We already had in section 3.1 the basics with exponentials. We have things in 3.2 like the one-to-one property of logs. We were kind of building up with logs for a while. They were kind of weird. So let me just quickly show you why it is what it is, and then tonight work on the basics some more so that tomorrow when you come in and things get harder, you're not totally lost just staring at the board being like, I never got logs, I never will. You have to know the properties, you have to know the formulas, you have to struggle through the basics so that you can play. And if you can't play, it's just like, well, this is boring, this is lame, I'm just sitting here staring at the board. That's no fun. So work tonight. If you guys figure out that, you could break down 32 to be a power of 2. Sorry. One-to-one property, x equals 5. How is this a one-to-one property also? Well, some of you are just like, duh. To be 0, they have to be the same. Okay, but others of you, we could have moved it to the other side. Oh, sorry, it's supposed to be a 3. One-to-one property of log says, hey, if they have the same bases, one on one side, one on the other, of course x has to be 3. But if you want to be super snazzy, couldn't you have used the inverse property and actually gotten rid of the ln's? That's cool too. Either way, x equals 3. This one, how can I rewrite 1/3? 3 to the negative 1. That's to the x. How can I rewrite 9 as 3 squared? I'm breaking down my big numbers and making fractions into negative exponents. Because then 3 to the negative x is 2. X must be negative 2. Ooh, we couldn't use one-to-one property. We couldn't rewrite e to look like 7 or 7 to look like e. So your only option on that one was the inverse property, which says, how do I undo ln? Sorry. How do I undo e? Awkward. What you do one side, do the other. X is ln of 7. Done. Inverse properties. What you're practicing tonight. Inverse properties. This one. Anybody think of the snail? I can make it log base 10 and 10. Oh, I did the snail the wrong way. That's fine. 10. So the negative 1 power is x. I could say 10 to the negative 1 is x. And then 10 to the negative 1 is 1/10. The other way is the inverse property, which says, what's the inverse of log base 10? Look at your calculator. It tells you 10 to the x is 10 to the negative 1, which is 1/10. Last but not least, how do I undo? Let's use the inverse property one last time. A log base 3. 3 to the x is equal to 3 to the 4th power, and then I just said, hey, 3 to the 4th, isn't that just 9 times 9? Which is 81. Come tomorrow, ready to play, but some of you need to work to get there. Bye, guys. 45 seconds early. Spoiled run. Ivy! This is your notebook.